provider backbone also is used for transporting all the client routing information stuff. Okay, so it could be that there are more than one label in transport. There could be one label for, okay, this packet has to go to this PE router. Then there could be another label which says, okay, it should use this traffic path. And then there could a third label which says, okay, and it's traffic for customer VPN A. So there could be some more labels than only one MPLS label on the traffic. Okay. On the other side, you can have more than one customer site connected to your PE router, which means you got one customer green and one customer, say, red. It isn't red, but I don't care. Then you need on your router side something called VRF, or Virtual Routing and Forwarding Instance, which means you get something like a virtual router on the router itself. So you get for each client a virtual routing instance, and this is absolutely needed because you shouldn't mix up customer routes with your global routing table, which just includes backbone routing information. And on the other hand, you shouldn't mix up routing information from two different customers. So, but because you got these virtual routing and forwarding instances, it's absolutely possible that two different customers can use the same IP address space. So you can have a 10.2 square something network in a green VPN, and you can have the same network in another VPN. Your backbone don't give a shit about the actual used IP address because it's only forwarding on MPLS traffic information. Okay. By the way, inside your backbone network, you will speak multi-protocol, BGP, to share the customer routes and stuff like that. Okay, we're short in time. I will skip this. If you're interested, just come to our workshop. So, one, for the trust model of MPLS, it's absolutely necessary that you got a trusted core assumed. Once an attacker is in the trusted core, it breaks your security model. If I'm inside your MPLS core, I can do nearly everything I want. You will see. But this means by the design of the technology, there is no attack from outside the core possible. Because outside the core is only a customer network, and this will be forwarded transparently. But there are no additional security controls available. So you can't say, okay, please secure this MPLS VPN with that key, something like that. That means if you're a customer of such an MPLS VPN, yeah, you can only trust your provider. Or, okay, there is something in the MPLS context. Is another routing protocol. No, it's not a routing protocol. It's LDP, the Label Distribution Protocol, which you can secure with MD5 too. But, okay, you've seen MD5. Okay, do some brute forcing stuff and get the key. So, on the other hand, this LDP only is spoken inside your trusted core. So why should you secure a protocol spoken inside a trusted core? In a core with no attacker inside, there is no real threat model for this. Okay, but this leads into some really grim debates between Corp Global Network Team and corporate information security. Because network team says, okay, yeah, it's MPLS, it's fine, just trust the provider, throw packets in, get packets out. But the InfoSec team says, okay, and what is with the
confidentiality, and is there some encryption in place, and why it's called VPN? Okay, it's called VPN, it's virtual private network, but it has nothing to do with encryption or something like that. So if you say MPLS VPN, you will never have encryption if you don't have other mechanisms in place, for example, speaking IPsec or something like that over the MPLS.
Yeah. Okay, so there are some words out of the bullshit bingo which appears directly here. If you go to your network team and say, okay, what is with an attack from inside the MPLS network? You'll say, okay, come on, nobody will ever try this. Or, oh, come on, you're paranoid. Just trust your provider. So, okay, for a long time, all these attacks were only theoretically. Now, we invented a tool. It's called MPLS Redirect. It's just a proof of concept for attacks on MPLS. It assumes that the attacker is inside the trusted core. So, again, we don't talk about how to get into the core. We talk about what to do once you are in the core. It's a short command line tool, and it modifies the VPN labels of your MPLS traffic. So it redirects traffic from one customer side to a different customer's side. Okay, we will have a short demo for this again. First of all, that's our setup. We got, oh wait. Okay, sorry for that, but we plan to present with the other notebook, so I could do this not on the beamer. So, okay, that's it. Again, we got two different VPNs. We called, okay, we're in Holland, so we called the one beer and another one spliff. And we will show you, you see they got both the same IP address spaces. This is the 113, this is the 112 network. And we will demonstrate that it works like it should, that you can ping from this VPN side a notebook in the other VPN side. So, which means to, because we got enough devices, I will use the virtual PE on the one side and ping Simon's notebook in the other network. So, just, okay. So, he is in the red VPN, and I go to ping him in a red user context. This should be your address. So, okay, this is working. I did a ping from the red customer's virtual routing and forwarding to the network on the other side, and it's success. You can even see in the Wireshark all the packages. They're wearing an MPLS label. So if I try to ping out of the context of the green customer, this ping will time out.
The green customer in this demo has the same IP address space, but my box actually is connected via the red, so it's not reachable.